only you have to find it out. What are the other factors that are given in the problem? What are the various other factors that you are having in the problem? When you know by this time what are the various factors, how to identify
Differential
it, what will be
factor.
the corresponding slope. So you are having an unknown constant gain that you have to determine. Then what is the other value? S squared. What is S squared? Derivative factor or an integral factor?
Derivative factor.
Derivative factor of what order?
Second one.
Second order.
Second order. So what will be the slope? It is the numerator, so plus 40 will be its corresponding slope. Okay. Next, moving on to 1 plus 0.2s. What type of factor is it?
Derivative.
That is a first order factor in denominator. So since it is in denominator, it will be a descending slope of what value? Minus 20, because it is first
Minus
order.
20.
Okay. Then what is the last factor that you are having? This one, last factor is also a what
First
factor?
order factor.
First order factor, again in denominator. So what will be the corresponding slope that we will be having? Again minus 20. Okay. Then
Minus
first
20.
thing you need to check is whether it is in time constant form or in open pole zero form. That you will be checking, time constant form. It should be of 1 plus st format that you are going to check. So is it in time constant form or not a time constant form?
Time constant form.
Time constant form. So you can proceed. Alright. Suppose on the other hand, if you are being given s plus 2, then you have to take out 1 2 from the equation. Then you will be writing 1 plus s by 2. Okay, you have to convert that into time constant, and then only you should substitute s is equal to j omega. Remember this. Okay. Next, after identifying the factors, you have to substitute s is equal to what value?
J omega.
J
J
omega.
omega. Okay, every place where you are having s, you need to substitute s is equal to j omega. So if you do that, the transfer function will be rewritten like this. Then next thing is, initially you have to assume k is equal to 1. Okay, initially you need to assume k is equal to 1. So they have assumed 1 here. Alright. Next thing is, you need to find out the corner frequencies. So you know what is the formula for finding out corner frequency? So what will be the formula? So what is the formula for finding omega c? General formula
1
is
by
1
T.
divided by 1 divided by
1 by
t. So if you do that, the first corner frequency, this is for this term, t is equal to 0.2. So omega c1 they have found out to be what value?
5
5
radians per
radian
second.
per second.
5 radians per second. Next, what about the next factor that you are having? Next factor is also a first order factor where t is now equivalent to 0.02, for which what is the corner frequency that they have found out?
50
50
radian per
radian per
second.
second.
50 radians per second. So you have found out corner frequency. Next you have to do the tabular column, and this is the tabular column that you are having. Always the first term, as you can see, will be what term? Here the problem is having integral or derivative or gain?
Integral.
Derivative.
Integral of what order? Second order. So that will be your first term always, and followed by the remaining terms with the in increasing order of corner frequency. So what is the least corner frequency and what term is contributing it?
Omega C1.
Omega C1. Omega C1 is contributed by what term? That first order factor in the denominator, that is 1 plus 0.2 j omega, that is giving the least corner frequency. So that term should be coming second. Okay. And finally third should be the next one with the highest corner frequency, that is 50, that is contributed by this term. Okay. Next thing is you have to mark the slope. Already I told you what will be the slope for all these terms. Since this factor is factor in the numerator, we will be having a plus slope only, and it is of order 2, so what will be the slope that we will be having? Come on people, the slope criteria I have told you so many times.
49.
So
Plus
plus 40
40
will be the slope. Next, this factor is in the denominator, so it will be a minus slope. This factor will also in the denominator, so it will be a minus slope. So minus minus you are having, and both are of order 1. So the slope will be minus 20, minus 20. Okay. Next you need to calculate the change in slope. So how will you do that? Change in slope. The initial value of slope that you are having is 40. So the curve will start with 40 dB per decade slope only. So bring it here, then you sum the slope with minus 20. So 40 minus 20, what will be the resultant change in slope?
20.
20 dB.
20. So this will be the next change in slope. Again, you bring this 20 here, sum it with minus 20. So what will be the final slope change that you are having?
0.
0. Okay, so the curve will start with 40, then you will have a drop of 20, and then you will be seeing a drop of 0 dB. Okay, that we will see now. Next thing is you need to choose the two other additional frequencies. What are the two frequencies that you will choose? One lower frequency that is less than omega C1, one higher frequency which is greater than omega C2. So what values they have chosen in the problem?
0.5 and 100.
Omega L they have chosen it to be 0.5. Omega H they have chosen it to be 100. Okay. And for omega L, omega H, omega C1, omega C2, you need to calculate what is A. A represents your magnitude in dB. That should be calculated next. So first, up to first corner frequency. Okay, up to first corner frequency, which is equivalent to how much value? 5 5 radians per second, no? What is omega C1? 5 radians per second, isn't it? 1 divided by 0.2 is 5 only, no?
Yes, ma'am.
Okay, so up to first corner frequency, which term will be contributing gain?
The
First
second
term. What is the first term in the table?
First term, J
K,
omega.
J omega square. So up to the first corner frequency, you will be having the gain being contributed by the first term in the table only, 20 log omega squared. So if you are calculating the gain will be minus 12 dB for lower frequency, that is 0.5. Okay, 0.5. The gain will be minus 12. Okay, and for first corner frequency, that is 5 radians per second, you will be having the gain 28 dB. And next onwards, the formula will change a little bit. So what will be the change in the formula that we will be having? Come on, I have already told you what will be the formula. I will load it again because the pen markings are not visible. Okay, so this is your omega L 0.5, the gain value is minus 12 dB. This is for 5 radians, that is omega C1, the gain will be minus 28. For these two factors, the gain contribution will be by J omega square factor. Okay, and here onwards the formula will change a little bit. So what will be the slope formula? Suppose if you are having omega C2 value, it is 50 radians per second. 50 radians per
50.
second. What is the formula? Slope change from the previous frequency is omega C1 to the present frequency is omega C2 into log of omega C2 divided by omega C1 plus the previous gain. So if you do that, the answer that is shown here will be what value? 48 dB. And finally, for the higher
48
frequency, same formula. Now the slope change will be from the previous frequency omega C2 to present frequency is omega H into log of present frequency divided by previous frequency. The previous gain is minus 48. So if you use this, the answers you will be getting it as minus 12, 28, 48 and minus 48 or something. Okay, both are 48 only. Now we will transfer all these 4 points to the graph Bode plot. Before that, we should also find out what is the phase angle. So how will you find out the phase angle? Phase angle from this, what is the phase angle? Phi. That is the angle of j omega I want. So what will be the formula? In the numerator, one derivative factor of what order is there?
Second order, ma'am.
Second order. If 1 omega is
Yes,
present means
180.
the angle is 90. Okay. If order is 2 means the angle will be 180. Okay.
180.
The remaining 2 terms are in the denominator, so minus you have to specify for this factor. So for this angle is 180. For this angle is tan inverse of what? The imaginary part is 0.2 omega divided by 1. Okay.
Omega.
Same fashion,
One.
what will be the phase angle for this one? Tan inverse of 0.02 omega divided by 1. Now you have to sum.
0.02.
Now you need to sum all these things in terms of single expression. So what is the phase angle now? Finally 180. The remaining terms are in the denominator. So minus tan inverse of 0.2 omega minus tan
0.2
inverse of 0.02 omega.
0.02.
Okay. Now this expression you need to substitute different values of omega and you need to find out what is the phase in degree. That will give you phase plot. Okay, they did it. So when you are substituting omega is equal to 0.5 in the same formula, we have discussed this formula now. This formula, if you are substituting 0.5 everywhere, then you will be getting what value for phase? 174. Similarly, 1 if you substitute means the angle is minus 168. If you are substituting 5 means the angle will be 130. So omega values, all these things you need to substitute in this formula. Okay, then you will be obtaining the phase values. Now with these 2 tables you need to obtain the Bode plot. Now we will see to the plot. Okay, this is a plot that is being present, shown. Again, what are the magnitude values that you are having? Have you written down? Have you copied? Here I have taken A scale, that is magnitude scale. So you are having 0 dB here. Upwards I have taken a positive and downwards I have taken a negative value. So 0, 10, each unit, 10, 10 units, 30, 40, 50. I have taken scale like this. Minus 10, minus 20, minus 30, like that you have to take scale. And then you have to mark the points. Okay. Then omega is equal to the least value of frequency, that is 0.5 radians per second. The value 0.5 will be coming here. Okay. This is 0.1 if you are assuming, 0.5 will be at this point. So this is A point where the corresponding slope is what value? A point is corresponding to what? Minus 12. That you mark it. The next frequency is what frequency? Omega C1, which is given to be 5 radians per second. So suppose if this is chosen to be 0.1, the corresponding frequency will be 1. I want 5 here. This is my 5 omega C1 frequency for which the slope is, this one. What is the value? We obtained from
0.
formula 0.
0 28.
28. Okay, 28. So this is my A point for omega L. This is my B point for omega C1. Next we will move on. This is my omega C2, which is my 50 radians per second, for which the gain value is what value? 48. Okay, the third point, C point. Then finally, this is my D point, where omega h is a frequency which is chosen to be 100 radian per second. That is
Yes, sir.
also equivalent to 48 dB. Okay, so just like cross marks that I am showing, you have to fix points. Then using a straight line, you have to join these. Okay, so you have to join all these points using a scale. That will be your magnitude plot. Initial slope is 40, you have to write, then 20, then it will be 0 dB. Okay, all these things should be marked here. And similarly, when it comes to marking phase plot, okay, so these are the points that you are having. These points, okay. From the table that I have shown for phase angle, you have to mark all these points. Then again, you have to join all these by a smooth straight line. You will be getting phase plot. You have to write it as phase plot. Okay. Now, what you need to do is, you need to find out K value. This graph you have drawn for what K value? K value is 1. Assumption that you have made that K value is equal to 1 and you have drawn this magnitude plot with K is equal to 1. But actual value of K you have to find for what value of omega GC they have specified in the problem. In the problem statement they have asked you to find the value of gain for what gain crossover frequency?
5 radian per second.
5 radian. So what is the meaning of gain crossover frequency? Where the magnitude will be equivalent to
0.
0 dB. So where you will be having 5 radians, this is 0.1 radians, means this will be 1 radian. So here you will be having the omega GC is equal to 5 radians per second value. Just to extend so that it meets your magnitude plot. Like this, you extend. And check out what is the gain value that you are having here. So what is the gain value that you are having? Zoom a little bit. What is the gain value that you are having? I have circled, no?
28.
28.
28.
But this at the point of omega GC, the gain should be 28 as 0 dB. That is my question.
I'm 0 only.
0 only. So what will you do? You will shift the curve so that at that point the gain becomes 0. Okay. So how much shift you have to make? Downwards or upwards?
Minus 28.
Minus 28. So you need to shift the entire curve downwards so that the slope will be becoming or gain will be becoming 0 dB. So this is the shift that you have to make, and how much shift you have to make that you have to calculate, with the help of which you will be calculating gain. So you have understood now this concept. They have specified in the problem this omega GC value. Okay, omega GC value. But if you extend so that it meets the magnitude plot, at this point it should be 0 dB. But it is not 0, it is 28 dB. So what you will do is you need to fix this point to 0. Okay, at this point you need to have a 0 dB. So every point you shift downwards 28. This point also you shift downwards 28. Okay, A, B, C, D points you shift downwards 28. Since it is shifted downwards, it is minus 28 shift you are having. This is C point, you have shifted 28 downwards. D point you have shifted downwards. Now fix the points. Again you join the graph by a smooth line. So this value is shifted curve. Okay, where the curve is shifted downwards minus 28 dB. Now how to calculate? They have given K value is equal to something, isn't it, in the problem? What is the K value that they have obtained? They have found out the K value is equal to 0.0398. So how they have found out, I will tell you. Wait. There is a formula there. We'll load it again. Let's just show you the formula. Back. Load it again. So this is one last model, okay? They may ask you to find gain margin, phase margin, gain cost of frequency or gain cost of frequency, or they will ask you to find out the value of K for which you need to shift the curve. Here they have given gain cost of frequency. Similarly, they will give you phase margin, gain margin, and they will ask you to shift the curve, okay? So you should be ready to solve any problems. Okay. So you can see for yourselves, calculation of K, they have made one formula. What is the formula that they have chosen? Tell me. There is a formula that they have used, no? So how much shift you are making, and downwards or upwards?
28 downwards.
Downwards. So that shifted value you have to equate to what formula?
20 log K.
20 log K. Then from that you will be finding out K value. What is the K value that is given?
Simply 0.0398.
Yes. Okay. That is the K value that you have found out. For what frequency is given in the problem?
Ma'am, that was 5 radians per
5.
second.
5 radians per second. Okay. So there will be 3 chances. One problem they will ask you simply draw the Bode plot. That might be a possibility. Or the second chances they may ask you to find out phase margin or gain crossover, phase crossover. Third case is they will give some value, and with the help of which they will ask you to find out K by shifting the curve upwards or downwards. Okay. Alright. So this finishes off Bode plot problems for you. Next we will discuss what are polar plots, otherwise known as Nyquist plots, and those plots will be drawn on a polar graph sheet.
Ma'am, we don't know the axis of polar graph sheets.
Wait, I am telling you, no, I have not even started to explain what is a polar plot and how to draw. Wait. Okay, so this is how a polar graph sheet will look like. Okay, this graph sheet is called as polar graph sheet. All are able to see the polar graph sheet that I am showing.
Yes, ma'am.
Okay, so what does it have? Some small, so many circles it has, and what are the other things that it's having? This is called as polar graph sheet. 2 things it will have, okay. Alright, there are so many circles you can see here. Here one circle is there, here one circle is there. So many circles are there, no? So they will be representing magnitude. Okay, they will be representing magnitude. So what will the circles represent?
Magnitude.
Magnitude. So each and every circle will be representing one particular magnitude of the given function. Next. There are some radial lines, as you can see, branching out. This is one radial line. 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 All over you are having radial lines extending from the center. So they will be representing your phase angle. Understood? So what is the polar graph sheet actually? It will be having 2 things. Okay, in it.
Yes, sir.
What do the circles represent and what do the radial lines represent?
Circles equals to
Magnitude and phase
magnitude.
angle.
What does magnitude represent? These circles that you are seeing, that circles will be representing your magnitude. And these radial lines will be representing your
Phase angle.
phase angle. Okay, so this is what is called as your polar graph sheet. And same way, like you are plotting magnitude and phase as a function of omega in your semi-law graph sheet, here you need to do it in a polar graph sheet. That's all. Very simple when compared to Bode plot if you understand it well. Now I will tell you some basic concepts regarding polar graph sheets. Okay. Now you can see here some angle markings they have made. What is this angle representing? This angle is marked as what value? This angle, there are some angle markings. So whenever you buy this graph sheet in your shop, it will also have the same markings. So I told you each and every radial line is corresponding to what value? Radial lines are phase angle. So this is representing my 0 degree. This is representing my minus 10 degree. This is 20. This is minus 30. This is minus 40. This is minus 50. This is minus 60. So here I will be having my minus 90. Here I will be having my minus 180. Here I will be having my minus 270. So in which direction I will be taking negative angle? Clockwise or anti-clockwise?
Clockwise.
Clockwise.
Clockwise. Okay, always negative angles. 0. Okay, here you will be having 0, here you will be having minus 90, here you will be having minus 180, here you will be having minus 270. So negative angle clockwise. Okay, always negative angle clockwise. But what about positive angles?
Anti-clock.
This is 10, 20. So this will be my plus 90, this will be plus 180, this will be plus 270. So if you want to mark positive angle will be taken in what direction?
Anti-clockwise.
Anti-clockwise. Remember this. Negative phase angle means clockwise. Positive means you have to take in the anti-clockwise. So each and every radial line that you are having represents what?
Phase angle.
Phase angle. Okay. Next. Some other things also you should know. Okay. Generally, if you are having on a g of s, some function, okay, you need to substitute again s is equal to j omega, that will become g of j omega. Now, if I am writing magnitude and phase angle, then what will be the magnitude and what will be the phase angle? Modulus of g of j omega will be my magnitude and angle of g of j omega will be my phase angle, isn't it? So any function, I can write it in terms of polar coordinates. You know that this is r theta, that is polar coordinates. Same graph you can do it in an ordinary graph sheet also, but you have to convert this polar coordinates into what form?
Rectangular form.
Rectangular. Rectangular will be having real part and imaginary part. So if you want to draw it in an ordinary graph sheet, then you have to convert r theta into real part plus j imaginary part. Then you will be able to draw the same in some ordinary graph sheet. That's possible. But stick to one method, whichever is easy for you, you do it. Okay. This method when compared to Bode plot is very, very easy. And before discussing that, some more extra points you need to know that I will teach you, after which you will do the problem. So now you have understood what is a polar graph, isn't it? What is a polar graph again for one final time?
Ma'am, the circles represent the magnitude and the radial lines represent the phase angles. If we have to go in clockwise direction, then we have to take negative angles. If we have to go in anti-clockwise, we have to take positive angles.
Okay. Now, so one more thing, where the plot is going to start and where the plot is going to end, that you need to know. Now this triangle or this quadrantal diagram you should remember, alright? Always type will representing the start of the plot, where the plot should start. Okay, that is given by the type number. Okay, this is only applicable for a minimum phase system which is having poles alone. Okay, only for minimum phase system The type and order will be able to give you where the plot will start and where the plot will end. So which will be indicating the start of the plot? Type or order will be giving you start.
Ma'am, anti-clockwise will give me start.
No. Type and order you know how to identify from a given transfer function, isn't it?
Yes, ma'am.
So type will be giving you where the plot is starting. Okay. Order will give you where the plot is ending. Understood?
Yes, ma'am.
Okay. See, generally if you want to know, if you are having a minimum phase transfer function which is having only poles in the system, minimum phase transfer function is only poles, then type identification will be giving you where the plot is going to start. Okay. And order ID will give you where the plot will terminate. Okay. And then start of the plot is determined by type and order. That is possible only for a minimum phase transfer function. Okay. Now, if this is a quadrant that you are having, okay, this is representing your type 0 quadrant, this is representing your type 1 quadrant, this one type 2 quadrant, and this one type 3 quadrant. So this will be indicating start of the plot. Okay. Suppose if the transfer function is giving type 1, which quadrant will it start?
Ma'am, type 0. Second
Type
quadrant.
1 means second quadrant it will start. Okay, the plot will start over here. Then suppose if the type is 3 means which quadrant will it start? It will start in fourth quadrant. Okay. Now next concept is where the plot will end. That will be determined by order. So this is order 1, this is order 2, this is order 3, and this is order 4. So this will be indicating where the plot is going to terminate, where it is going to end. Suppose if the given transfer function is of order 4, then in which quadrant will it terminate?
Fourth.
This quadrant. Okay, understood? This concept is very, very important. Sometimes if you see to the figure, for example, this is your given transfer function. If you substitute s is equal to j omega here, it will become 1 plus j omega t. What is the type and what is the order of the system? Come on, immediately answer should come from your side. What is the type and what is the order of the system?
Type 0 order 1.
Type is 0 and order is 1. So where the plot will start and where the plot will end?
First quadrant.
Graph is also drawn here. Same, this is type 1, so type 0 and order 1. So this quadrant represents type 0 order 1. So same quadrant, it starts and it ends. Okay, this will be the shape. Suppose if you are having this system
Ma'am, can you explain this order part again, ma'am?
where it starts from.
Order. I got how to take the type, but I'm not getting how to take
Order
the
is 1, order 2, order 3, order 4.
Ma'am,
So
from
this
the
is
equation.
indicating
Ma'am.
it. Okay, from the equation. What is order? 1 only, no? 1, no? And s to the power 0. So type 0 order 1, na? Understood, Vivek?
Yes, ma'am.
Okay. Suppose if you consider this, then what is the order and what is the type of the system?
Ma'am, type 1 order.
Type 1,
Order 2.
order 2. So this will be your first quadrant, this will be your type 1, order 2. So the plot will start and end in the same quadrant. Okay, whenever you are varying omega from what value to what value? 0 to infinity, you have to vary the omega value, and if you are obtaining the plot, then the plot will start and end in the same quadrant. Okay, one more. Now if you see to this function, what is the order and what is the type of the system?
Ma'am, type 0 to 1. 0 and
Type
1.
is 0, order is
Order is 1 in the beginning, and then it is changing.
Order is 1 plus ST1, 1 plus ST2. How order is 1 for you? Order is 2, not 2 S factors are there. How it will be order 1? So that's,
Ma'am, from equation I cannot find out, ma'am.
how equation you cannot find out? This concept you have studied in second unit itself. Then what's your doubt? 1 plus ST1, 1 plus ST2, if you are multiplying, what will be the highest order of S in the denominator polynomial?
Square.
Then, what is the order?
2. Yes, ma'am. Okay. Found. Got.
Okay, so this will be your quadrant where the start will be indicated by type 0. Which quadrant type 0 belongs?
First quadrant.
This is your first quadrant, so it starts over here. Okay, this is start. This will be indicating your end. So where is your order 2 quadrant?
Second quadrant.
So this is order 1. So here you will be having order 2. So it starts over here and it's ending here. Okay. So this type and order identification for start and end of the plot is applicable only for minimum phase systems with only poles. Okay, it's not applicable if you are having zeros in the system. Okay. One more we will discuss. What is the order and what is the type of the system?
Ma'am,
Type 2, order
3.
Type
Order
is
5.
2.
Order
1, 2,
3.
5,
3.
4, 5.
Fifth order. Fifth order. So the start will be in what quadrant? First quadrant, second quadrant, third quadrant, fourth quadrant, fifth quadrant, like that it will go. Okay. So the start will be indicated by type 2. So this is type 0, type 1 and type 2. So it's starting over here. Okay. And then end will be indicated by order. Order is I think 5. So order 1, 2, 3, 4, 5. So it's ending here. Understood?
So my fifth quadrant
Again,
and third quadrant are the same thing.
you rotate the angle, it will be circling only, no. Only 360 degree you are having. Then how come?
Okay.
Okay.
But we will denote with type 5, order 5, and then we will mark in third quadrant.
Yes, where else we will go? There is no possibility, no.
Yes, ma'am.
Okay, with this, we close. One more small concept you will discuss. Whenever you are adding the pole to the existing system, it will observe at 90 degree phase shift. The entire curve will shift to minus 90. If you are adding a 0, it will shift plus 90. Okay. Like you are seeing the effects of additional poles and zeros to root locus when it gets shifted to left or right. Here it will be getting shifted minus 90 or plus 90 with the addition of pole and 0 that you remember might be asked in MCQ. Okay. Now we will move on to problem. All are having polar castries with you? No? It was late night since I message you must not be having. Are you having or not? Was that also silence? Okay, so what is asked in the question?
No, ma'am.
What is asked in the question? Sumit Gautam. Sumit Gautam, today you will be marked absent only. I am giving lenience. One fine day, my tolerance limit will be exceeded, and that day you will get punishment for all those who are not responding and doing something else. Hrithik Prince Kumar. Hrithik Prince Kumar and Sumit Gautam. Deva sir, what is asked in the problem statement? Dictate. You should not feel bad if I am marking Hrithik Prince Kumar and Sumit Gautam absent. Anyway, you are not present mentally. Deva,
Ma'am,
tell me what is given in the problem statement, man.
No need, Subramanian.
Read the question is what I told. I have not asked you any answer, calculation or anything else. What is given in the problem statement was what I asked. Can't you read and tell? Dictate only, I told you no.
The open loop transfer function of
The open loop transfer function of
unity feedback system is given by g of x equal to 1 by 1 plus square sketch the plot, polar plot and determine the gain and the mass.
So what do you need to do? What have you learned from the question? They have given you g of s. It is open loop transfer function or CLTF?
First you find g of JW.
G of j omega you need to find. Then you have to draw the polar plot. Then you need to find out what value. They have asked you to determine what value.
Yes value. No?
Determine gain margin and phase margin they have asked in the problem. Okay. So what is the transfer function that they have given? G of s is equal to 1 divided by s into 1 plus s the whole square. That is the transfer function that I have given, OLTF, for which they have asked you to draw the polar plot. And from the polar plot they have asked you to find out gamma and kg. What does gamma and kg represent?
Phase crossover frequency, gain crossover frequency.
Phase margin and gain margin. Okay. As usual, you need to first check whether it is in time constant form or pole zero form. No matter what, it is 1 plus s only. It is in time constant form. That is checked. Next thing is you need to substitute s is equal to j omega. So g of j omega, if you substitute, means what will happen? 1 divided by j omega into 1 plus j omega the whole square you will get. Or otherwise you can split this term in order to make it easy for calculation. 1 plus j omega. Okay. So they have split the square into two first order factors. If you want to keep it as such and solve, means no problem. It's your own wish only. So this square terms they have split it into two first order factors. Okay, that is what they have done. Next. So we can see here. Next you need to find out the magnitude of g of j omega and the angle of g of j omega. Okay, so you know how to find it out. So what will be the magnitude and what will be the angle of one factor, that is your gain. So the magnitude will be 1. So 1 is the magnitude, angle is 0. Okay, that is for 1. Now for this j omega factor, what is the angle and what is the magnitude? J omega. Come on, all these things are not new to you. 1 omega in the denominator. J factor. J means what will be the angle? Omega is the magnitude. J omega means omega
Minus
is the
90.
magnitude. Minus 90. Because the term is in the denominator, you will be having minus 90. So here you are having minus. Now next thing, there are two first order factors that you are having, 1 plus j omega. So what will be the phase angle and what will be the magnitude? Magnitude, if you want to write, means I always tell you the real part squared is 1, the imaginary part is omega square. Angle, if you are writing, means tan inverse of what is the imaginary part? Omega divided by 1.
Omega.
Okay.
1.
So this is how we will be writing the angle and magnitude combination. Suppose if you want to separate up angle alone and magnitude alone, then what will be the expression that we will be having? 1 divided by omega into 1 plus omega squared into 1 plus omega squared. This is my magnitude alone. Now what about phase angle? Phase angle expression is 0 minus 90 minus tan inverse of omega minus tan inverse of omega. This can be simplified as minus 90 minus 2 tan inverse of omega. Okay. So here you need to separate the equation into magnitude and phase angle. That is your first step. Understood this portion or not? Tell me now.
Yes, ma'am.
Ma'am, the 2 tan omega part, why that?
There are two terms which are similar angle, having similar angle, no? Tan inverse, tan inverse. So if you sum that, it will be becoming minus 2 tan inverse of
Yes,
omega.
ma'am.
Okay. So this is my magnitude and this is my phase angle. Okay. Now what I need to do is I need to substitute different values of omega ranging from 0 to infinity in both magnitude as well as phase angle expression. I will tabulate it and then I will proceed for drawing the polar plot. That's all. Very simple procedure here. Okay, that I will tell you how. Okay, what are the values of omega that they have chosen here? Tell me. See to the table column. Okay. This is my R, this is my angle theta degree. I have taken what values of omega here? Tell me.
0.4, 0.5,
0.4,
0.6, 0.7.
0.5, 0.6, 0.7. See, you first check what is your omega C value. That will be 1 divided by what? 1 only,
1
I
plus
think
omega
so. So
square.
around this value you choose. Okay, check out the corner frequency. In and around the corner frequency value, you choose omega value. So that they have chosen to be, you can choose 0 also. You can choose infinity also. Okay, no problem. Alright. But in and around the corner frequency, you choose these omega values. Okay. Corner frequency is coming around 1. So around that value they have chosen here. Okay, that you are going to substitute in these equations. So magnitude of j omega will be equivalent to 1 divided by 0.4 square root of 1 plus 0.4 square. Okay. For that, what is the magnitude that they have got?
2.2.
2.2. Same way, if you are substituting omega is 0.5, the same formula. 1 divided by 0.5, 1 plus 0.5 the whole square. Then what is the angle that you are having? Sorry, magnitude.
1.6.
1.6. Same way you substitute omega values, different values in this equation, then you will be tabulating all the values of magnitude. Okay. Then same way, if you substitute the same omega values in the phase angle you know minus 90 minus 2 tan inverse of omega. Suppose if omega is 0.4 means 5 will be equivalent to minus 90 minus 2 tan inverse of 0.4. So what is the value that you have got? What is the answer? I am not even asking you to do calculation.
Minus 130.
Minus 134. Now suppose if I want to find out angle value for 0.5, again in the same formula, minus 90 minus 2 tan inverse of 0.5. What is the angle that you will be getting?
minus 140.
143. Then same way, you substitute every value of omega in the formula for magnitude and phase angle, you tabulate all the values and you have to tabulate like this. Okay, then you will be transferring all these values, you will draw it in a polar plot. Okay, you take down the table in your notebook. I will ask you while plotting. I will not shift pages. Have you taken down? It will be easy for me to explain if you are telling me the magnitude and the phase angle values if I ask you. Are you taking down somebody?
Ma'am, I've taken screenshot.
Yes, ma'am.
Yes, ma'am.
The rest also have you taken down the values? Shall I ask from
Yes.
everybody? Come on, I will
Yes.
pinpoint everybody and I will ask what is the value of magnitude and phase angle for this value of omega. I will ask. All of you take down the table. Have you taken down?
Yes, ma'am.
Yes,
Okay, shall we proceed then? Okay. We'll proceed to the polar plot now. Now first thing is angle is already marked. It is standard. We cannot change it. Angle markings you cannot change. But magnitude marking scale you have to take. Okay. So what is the range of the magnitude? Tell me. It is ranging from what value to what value? Range of the magnitude. You have written the tabular column, no? What is modulus of g omega range? What is the least value and what is higher value?
134 to 185.
That is phase angle. I am talking about magnitude.
Oh, sorry. 2.2 to 0.4.
2.2 to 0.4.
So the magnitude is ranging from 2.2 to
0.4.
0.4.
0.4. So omega value is varied from 0.4 to 1.1. The range of the magnitude that you are having is 0.4 to 2.2. So accordingly you have to take scale. I will tell you. So here only you have to take scale. Okay. This scale. Here only you have to take the magnitude scale. So lower value is 0 as you told me. This is where I will be taking my magnitude. So how I have taken scale? Tell me. 1 unit you have to take. So this at this point I am marking magnitude is equal to 1. So this I will be calling it as what circle?
1 radius circle. 1 radius circle of radius 1.
So wherever the magnitude factor is becoming equal, the corresponding circle is called as what circle?
Unity circle.
Others also you have to tell me, because based upon this unity circle only you will calculate what is the gain margin and phase margin. So what do you mean by unity circle?
Circle with radius 1.
The rest also give me the answer. What do you mean by unity circle for a polar graph sheet? What do you mean by unity circle? Sitik sir, tell me what is unity circle? Brinda, tell me what is unity circle? Brinda, Deepesh, Thirumalai Vasan, what is unity circle? My voice is not audible to you. Hello?
Ma'am, circle with
Audible.
magnitude 1.
Audible.
Okay, then
Circle with
people are
magnitude
not
1,
asking.
ma'am.
The circle with the magnitude 1. So this one is 1.
Ma'am, circle with magnitude 1. Hello.
Okay. Alright. So here they have marked as 0.5. Okay, here 1, here 1.5, here 2.5. So this is how you will be marking out scale. You can take your own scale also, but the rate should be from 0.4 to 2.2. Within that you have to take scale. Okay, so this point is considered 2.5. This one is 2. This one is 1.5. 1.5. Like that. This is 0. So like that you have to take scale for magnitude. Understood magnitude scale marking? Understood magnitude scale markings or not?
Yes, ma'am.
Yes,
What
ma'am.
about the rest?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then already face angle are having their own markings standard given in the polar graph sheet, so you need not change anything. Now you have to fix out the points only. So what is first value? Omega is equal to what value?
0.4.
0.4. What is the magnitude for it? A. Modulus of G of J omega, you got it to be 0.4.
2.2.
2.2.
0.4 to
2.2,
2.2. 2.2.
Ma'am, G of J
2.2.
omega equals to 2.2.
2.2 is say. Okay, so 2.2 you are saying. So I have to mark 2.2 for 0.4. And what is the corresponding phase angle?
Minus 134.
So
Minus
2.2 is the magnitude. Magnitude is 2.2. Then what is the phase angle?
Minus 134.
Minus 134.
134. Okay. So where you are having minus 134, you have to check. Okay. So This is my minus 90. This is my minus 180. Between this only I will have 134. So this is minus 180, minus 100, minus 110. So this is my minus 130. Okay, this is my minus 140. So in between also there will be small radial lines. Okay, find out where is 134. So somewhere here, approximately I'm marking. But even in your graph sheets you will have in between lines. So no need to worry about that. So here you are having minus 130. This is minus 130. So here somewhere I will have my minus 134. And 2.2 is your magnitude you are telling. Just circle this line so that it makes your 2.2. So this is 2.25. So 2.2 you are telling. So if you are circling this, this will be my point. Understood how I am marking?
No, ma'am.
Very good.
Yes, ma'am.
Ma'am, I did not.
Just the face markings. What is the phase angle and magnitude learn? Okay, what is the phase angle you are telling? Minus 134. Corresponding
Minus
value of
134.
magnitude is 2.2. Okay.
2.2.
Now, where is minus 134 in the radial line? You are having so many radial lines, no? Where is minus 134? You have to check it.
Between 120 and 130.
Yes. So if you see zoom close, okay, this is where I am having my minus 130. Yes or no? Others also are you able to see
Yes, ma'am. But
Yes.
minus 130. So this is minus 140. Somewhere again some small lines you will have in the graph sheet. So find out where you are having minus 134. You circle it so that it meets the point 2.2. Where you will have 2.2 here. Somewhere here, no.
Yes, ma'am.
So both the points you have to intersect. So this intersection point will be there. I have crossed out, no?
Okay.
Understood or not?
Yes, ma'am. Yes, ma'am.
The rest also, if you have not understood, I am ready to tell it again and again. What about the rest, Maharaj, Satvik, Mohan Kumar, Mukul Patel, Mohit Pingley, Anusha? All understood how I am marking the cross points?
Yes, ma'am.
Yes,
What
ma'am.
about the rest who
Yes,
I have
ma'am.
called? See, in case if you are not able to understand, you ask. I am ready to tell it again. This way only you have to mark every point in the graph
Ma'am,
and you have to
if
connect
I
it
want
very
to,
smooth curve.
if I want to mark a smaller magnitude for the same angle, how will I do that? For example, if I want to mark something like
Like you are taking
0.4.
automatic scale, no, you can take, no problem. But if you are drawing a broad scale, depending upon the values you are getting, the curve will also be very good. If you are taking a
No,
small
ma'am.
range scale, means curve will be small, no.
I'm just asking, like, for in that angle minus 134, if the
Suppose if you are
magnitude
having, wait,
was 0.4, if the
wait,
magnitude.
wait. So
Sorry.
if you are saying 2.2 you are marking here, then again you have to circle. That point will come here. Very small graph you will have,
Oh,
isn't it?
oh.
Understood or not?
Yes, ma'am. Yes, ma'am.
What about the rest? Shall we proceed to the next point?
Ma'am. Yes, ma'am.
Yes, ma'am.
What is the next point? Tell me. This is the first point where the angle is minus 134, the magnitude is 2.2. What is the next one?
0.5, 1.6
0.5?
minus 143.
No, I don't want omega value. Leave out omega value. Only magnitude and phase angle you tell.
1.6
1.6 is magnitude. What is the phase angle?
minus 143.
Minus 143. Okay, so where you are having minus 143, this is minus 140. So somewhere here you will be having 1.6 is around somewhere here. And I will use a different color to do the marking. So 1.6 will be somewhere here. You circle it so that it meets your 143 somewhere here. So again a point. Okay, this is where 1.6 and minus 143 intersect. Understood? Second
Yes.
point. What about your third?
1.2 and minus 151. 1.2 is the magnitude.
1.2 and
Minus 151. Phase angle minus 151.
151. So let's do it in a different color. So 1.2 will be somewhere here and 151 is over here. So 151 will be, this is 1.2. Just I am circling it. So here I will have 1 point. Okay. So this is 1.2 minus 151. What about the other points?
1 and minus 159.
1 and
Minus 159.
minus 159. So this is my 1. You circle it so that I'll get around 160. So this is the point where I am having 1 and minus 159. Then what is the next point?
0.8167. Minus 167.
0.8
minus 167.
minus 167. So 160 is here. So in between you will have 167 at some point. Okay, like this you mark all the points, the cross points, and then what do you need to do? You need to join all these points by a smooth curve, like this. Join all these points by a smooth curve. Okay. Alright, and this is a minimum phase system or a non-minimum phase system. What is the given transfer function that you are having? G of s is equal to 1 divided by s into 1 plus s square. What is the order and what is the type of the system?
Type 0, order 3.
Please.
1 plus s. S into 1 plus s
It is
square.
starting from second. Yes, yes. Okay, whatever will be there. So type here it is starting and it is ending at the third quadrant. Okay. So you can cross check by type and order where the plot is starting and where the plot is going to end. What?
Ma'am, how to mark omega values in the plot?
Omega value no need to mark. Just they have written corresponding values of omega. No marking of omega is necessary. Okay? Alright?
Okay.
Understood. Only magnitude and phase angle where it intersects. At that point you have to keep cross points and then you have to join it by a smooth line. Now I will tell you how to find out gain margin and phase margin. You please remember. Please shall I clear the page? Have you understood? Okay.
Yes,
Now what is gain margin? Gain margin is obtained at what frequency? Gain margin, what frequency? Phase crossover frequency. Phase crossover frequency, what phase angle?
180.
180. Okay. So now I want to find out gain margin. Gain margin corresponding frequency is omega pc. That means wherever the phase angle is minus 180 degree. That I have to find out. Okay. Now, you know where is minus 180, isn't it? This point is minus 180. Right? This point is minus 180. So, where it hits, here only it hits, no? That this is the curve that I am having. That is intersecting at that minus 180 degree at this point only, no? Are you able to understand?
Yes, ma'am.
So, you determine how much is the magnitude. Okay, modulus of g of j omega. So, how much is the magnitude that you are having? Again, I will clear the page for your sake.
1.
So, here only it is hitting the minus 180 degree axis, for which g of j omega pc you need to mark. So, not 1, less than 1 only. So, what is the value? Here, this circle only you are having 1. This is 1. So, half only you are having. At that point it intersects. So, let this be 0.5. Okay. So, that reciprocal you have to take. This is unity circle is marked very bold, no. At this point only the magnitude is 1. The curve is intersecting minus 180 at this particular point. So, what will be the magnitude?
Half, yes, ma'am. Okay.
Early almost half only, no. So, that is 0.5 you assume. The reciprocal of that will be equivalent to kg. So, what is reciprocal of 0.5? You are having calculator. What is 1 divided by 0.5?
2.
2. So that is called as what margin?
Gain margin.
Gain margin. Okay, that is how you will be finding out gain margin.
I'm not audible, ma'am.
हेलो
Hello.
Hello.
हेलो आवाज आ रही है
हाँ आ रही है
हेलो
अटेंडेंस ही नहीं लिया
हेलो
मैम.
बोलो
डुप्लेसी आउट हो गया भाई
मैं
वॉटसन
चुप
भी
बैठ
आउट हो
मैं
गया
राजमल लालवानी
मेरी आवाज आ रही है
शार्दुल शार्दुल स्वाद आया कल रात को
माथा मत खराब करो मैं तुम्हारे घर पे आके तुमको मारेंगे हम
बाप रे बाप कल तो
पीयूष तो बहुत खुश होगा साला
भाई 10 ओवर तक
पीयूष
मैं बहुत नहीं राज 10 ओवर तक मैं बहुत टेंशन में था हार जाएंगे 10 ओवर के बाद तो 12 ओवर के बाद तो मैं समझ ही गया कि पार है
Who won yesterday?
अरे वो
Very nice IPL chat you are making. Who won yesterday, man?
मैम
KKR Kolkata.
KKR versus who was the opposite
Chennai
team?
Super Kings.
Chennai
ma'am.
CSK
Chennai Super Kings lost again.
Yes,
Very good.
वेरी गुड
why very good
very good man
Kolkata, ma'am. Don't give them attendance, ma'am.
yes
Okay,
ma'am
with this we'll close class. Again, tell me how you will find out gain margin. Face margin, I'll tell you after that we will go off. Okay. So how will you find out gain margin? What is the procedure?
Ma'am, omega phase cross frequency equals
Wherever you are having minus 180 degree, this line is minus 180 degree. So you need to know where the curve is cutting that axis. So at this point only it cuts. Corresponding magnitude you have to note it down. 0.5 for which you have to take the reciprocal. That value you are seeing that is obtained to be 2. Okay, now I will tell you how to find the phase margin. Now phase margin corresponding frequency is what? Gain margin means corresponding frequency is phase crossover. Phase margin means corresponding frequency is gain crossover. Gain crossover frequency means what is the magnitude?
0 and
0 or 1.
And 1.
Okay,
Or
0
1.
dB. But here you are not taking dB scale. You are taking ordinary magnitude. So what should be the magnitude? Magnitude should be 1. So 0 dB or 1. You remember that? So this is my unity circle. Okay, this is my unity circle that I have bolded. Wherever you go, the magnitude will be 1. That circle is called as 1. So you can see the curve. The curve that you have drawn, where does it hit this unity circle? You have to see. Okay, so it's hitting at this particular point. What is the corresponding phase angle you have to mark? Phi value you have to note it down. So what is the phase angle they have marked here? I will zoom it a little more.
Minus 115.20.
Minus 159. So that will be my phi GC value. Then you know the formula for gamma. What is the formula for gamma?
180 plus 5G.
180 plus 5 GC.
Plus.
So 180 minus 159. So what is the value of gamma now? Phase margin?
21.
21.
21.
We'll check with the answer. 21. Okay, this is how we'll be finding out gain phase margin. Anybody has doubt in finding out gain margin, phase margin from polar plot? This is also called as Nyquist plot. What about the rest? How will you find out one final time, gain margin, phase margin. Phase margin you tell first. How will you find out phase margin? Wherever you are having that unity circle, this is your unity circle, you have to check out where the curve is cutting that unity circle. Corresponding phase angle you have to note it down. Okay, corresponding phase angle you have to note it down. That will be substituted as phi GC in the gamma formula. Then you will be getting phase margin. Okay. Now, how to find out gain margin? One more time, finally.
180 plus 5 GC
This is
formula.
minus 180 degree axis. Where the curve is cutting that minus 180 degree, the corresponding magnitude you have to note it down, and then you have to take the reciprocal of that magnitude at phase crossover frequency. That's all. Okay. This is easy or body plot is easy for you?
Ma'am, this is easy.
But you have to remember that polar plots are hard to come. They don't usually give polar plot. Only Bode plot is very, very important. So you have to double concentrate on Bode plot. Okay. So with this, I'm hoping you understood. Next class, I will try to solve one more problem on polar plot, and I will start one more criteria, Nyquist stability criteria. Okay. You will be having for CT2 this unit fully, the previous unit fully, plus the first unit signal flow graph that you have left off. All are included for your CT2. Okay. I think your exam falls on October 14 or something. I will be taking question paper. I will try to set a very difficult one. It will be time management only. I will talk to the coordinator and I will split it into 3 sections. Each and every section I will put one timeline. Okay, strictly. If it is MCQ means I will just give you 15 or 20 minutes to finish up. Alright. Then part B I will try to give short answer or fill in the blanks. For that also I will separately give some time deadline. Okay, within that you have to submit. Okay, I'll try to make it hectic this time. So let me see how it goes. So with this we can go off.
Ma'am, easy
Same way you will have exam if you are being asked to come personally and write. So you should adjust with everything. So now you are free to go. Okay, all can disperse. I hope you understood. All have understood, polar plot and Nyquist plot.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Again, I'm telling you this graphical portions, once you understand, it's very easy. Each and every plot that you will be given will be carrying 16 marks. So better concentrate more on body plot. Very, very, very important concept. All
Ma'am,
can
how
leave.
much
All
marks
of you to
CT2,
go.
ma'am?
This is CT2, 50 marks, I think so. It will be a 2-hour question, 2-hour paper, I think.
No MCQ?
I will try MCQ, maybe 10 I will give on section. Part B I will try to put in filling the blanks plus in combination with the short answer. Let me see how it goes.
Okay, ma'am.
Most probably everything will be MCQ only, but long. Every section will have, I will put timeline which I have not yet decided. I have to talk with others also.
Okay, ma'am. Thank you, ma'am.
On all can leave.
Okay, ma'am.
Thank you, ma'am.
Okay.
Thank you, ma'am.